Problems are they totally fit into this chapter as far as sequences and series, but just want you to know that they're different as far as how we solve them. We're not just cranking through a formula. We're going to use that finance solver in a calculator. But first of all, we want to be able to put a recursive function that represents this. I want you to be able to do that. So we always start those. You have to have, the initial amount. So a sub 0 is the initial amount, and for this situation, obviously, that would be the 1,000. I want these to start as, the nth term equals, okay? And then what did we have? Well, we had the 1 plus r over n, so the r here would be 0.0325, and we would divide by the n. Well, the n is the number of times it's compounded in a year, so that would be 12 for here, so divide by 12. All right, and then we multiply that by a to the n minus 1, which is literally what makes it recursive, and then we tack on whatever we're putting in each month. So I'd love for you just to get the habit of being able to kind of understand the recursive formula and the initial amount. All right, so now is where we're going to actually start putting stuff into our calculator. All right, so I'm going to go to, I'm going to see if I can make this a little bit bigger. Okay, so I'm going to go into here. I want you to be able to kind of see this a little better. So if I go to my menu, and then I go into finance solver here. Okay, so for this problem, I got to remember what it was. Hold on. We're going to put in 1,000, 35, reach 12,000, 3.25. Okay, so we can put in right here 3.25 because the problem said right away 3.25. The present value of that problem is negative 1,000 because we put in as negative on the calculator. The payment is 35, so we put in negative 35. So the payment and the present value are put in as negatives there. All right, and then the future value was told to us in this problem. They want that to be 12,000. Okay, payments per year. It doesn't matter how many years we're doing it. Per year, we would have 12 payments according to the problem, and it would be compounded monthly. So that's a 12 there. Okay, so now we are actually trying to, this is the only one we don't know here. So we hit enter on that one, and it actually says to us 215.27. Well, what that means is those are months. So, how long will it take? You're not going to get it. It's 215.27. You won't get it on the 215th month. You'll need 0.27 more, which means you'll need a 216th month because you only deposit money monthly. So after 216 months, you will actually get 12 G's in there. All right, so now a little different. So now we're saying start with 2,500. How much should he deposit each month? So we're going to look that up to get 6,000 in 4 years. Okay. So, whoa, that's not what I wanted to see. Where are we at? Right there. Okay. So now I'm going to make this a 48. And the reason is they talked about it being 4 years. So 4 years times 12 payments would be 48. 3.25 was stayed the same. This time they said put in $2,500. So start with 25. And this part I'm going to actually make 0 for now because that's what the question's asking. And then we want to know how long is it going to take to make 6,000. Okay, well, 12 is still the same. Like PPY and CPY are going to stay the same. But if I go up to the payment and hit enter, it says $61.61, basically, if we round that. Okay, so how long, how much would I have to do? I'd have to put away $61.61 each month in order to get 6,000 in the account in the first 4 years. So that's how we go about those. Second one down here. Philin Banks, get it? I hope you got it. Philin Banks decides to get some money away from retirement. All right, he will retire in 10 years, so 10 years. He feels safe that he can average 5% annual interest. Is he better off starting an account with 16,000? Okay, so we're going to put in 16,000. This is literally why the finance solver is great, because you can just play around with different scenarios. Put in 16,000, so that's his initial, and then deposit the 500. Just be careful. We're doing this in quarters. We'll talk about that in a second. Or is he better off putting in $22,000 and depositing 400? Okay, so we can play around with this on the finance solver. Remember, 5% and then in 10 years. All right, so here's the deal on the finance solver. I'll put this, I'm going to go on a progression here that hopefully will help you understand this better. So 5% there. The payments per year are not 12. All right, that's why I bolded the quarter. Quarterly means, you know, once every quarter, which is every 3 months. So we're going to do that. Payments per year at 4, and that means we're compounding per year at 4 as well. All right. Future value, we actually don't know. So we can get that out of there in our brain. The payment that we're putting away for this first one is 5. Let me delete all this. 500. So negative 500. And I believe it was, I don't remember. I just don't remember. 20 something, 20,000. Sorry, 16,000 and a $500 payment. So present value would be negative 16,000, not 100. Putting away 500. Okay, but the number of payments you're making for 10 years would actually be 40 because you're making quarterly payments for 4 years. So 40 actual payments. So when we go to the future value, we will see that he will have $52,042.69. $52,042.69. See if I can remember to do that. Okay, so $52,049.69. I think that's what I said. Oh well, let's go back and try. Now we got to adjust 22,400. That's all we got to do. A little adjustment and see how it goes. Same amount of time. So now we're putting in 22,000 because we can afford it, but apparently he can't afford as much a month. So everything else stays the same. We hit enter there, and that comes out to 56,755. 56,755.45. Okay, so clearly putting in 22,000, putting in more and paying less per month is going to get him in a better situation. All right, I really hope these videos help you and you're trying hard.